and my friends. Presentation about IoT parking system with the application of non-MCU ESP8266 and Blink. For the first one is introduction. The concept of the Internet of Things IoT started with things with identity communication devices. The devices could be tracked, controlled, or monitored using remote computers connected through the Internet. Monitoring is an important thing to make sure whether a system is functioning well or not. Massive increase in the number of automobiles on the road, along with the poor management of the existing parking spaces, has resulted in parking issues. A parking system connected to the Blink application from the mobile app is implemented with the concept of IoT to monitor the availability of parking slots in area. Next is problem statement. Unavailable to find parking slots in time contributes to the one of the causes of traffic congestion in urban, as drivers cannot readily know the available parking slots and have to waste time to search parking slots one by one. Searching for available parking slots one by one causes unnecessary food consumption and time consumption. If there is a way for the driver to readily know which parking slots are available, they can plan their parking routes beforehand without wasting too much time and fuel to find parking slots. Objectives. The first one is to develop an IoT-based parking system, which the sensors installed for each parking slot can successfully determine the availability of the parking slots and conveys to message to the microprocessor. Second is to develop an internet platform, which is mobile apps, to receive the data from the microprocessor via the internet to know the availability of the parking slots in real time. That's all from me. Thank you.
My name is Chao Chin and I will continue with the presentation. I will talk about the application of components for this system. First is the Node MCU ESP8266, which is a development board specially targeted for IoT-based application. It has one analog input pin, 16 digital I/O pin along with ability to connect with serial communication protocol. The application include prototyping for IoT device, low power, battery-operated application, and project requiring I/O interface with Bluetooth and Wi-Fi capabilities. Next is the infrared sensor, which is an electronic device that measures and detects infrared radiation in its surrounding environment. The basic concept of this sensor is used as an obstacle detector is to transmit an infrared signal. This infrared signal bounces from the surface of an object and the signal are received at the infrared receiver. Next is a solderless breadboard. It is used to build and test circuit quickly before finalizing and soldering any circuit design. It has many holes for the resistor to be inserted. Connection layout include top and bottom distribution rails, where top and bottom holes are connected horizontally, while the center section is connected vertically in 5 holes as a set. Following is the jumper wire, which are simple cables having connector pins on both ends. It commonly used with breadboard. The wire used for this project will be male to female connector, where the male pins will connect to the breadboard and female pins will connect to the IR sensor.
Hi, I'm Lee Jun, and I will be explaining about the methodology and the results for this project. After we have prepared the device, which is Node MCU ESP8266 with 5 Wi-Fi module, infrared sensors, breadboard and jumper wires, we will continue with the methodology. There are 3 main steps for this project, which is code programming for Arduino IDE, and setting up the Blink app, and finally set up for circuit and parking layout. All these steps are compiled and run, and we will obtain the data and results. If we have successfully obtained the desirable results, this project is considered complete. This is the code programming for the Node MCU ESP8266 using Arduino IDE. Firstly, we will define blink print serial. This is to disable prints by blink library and save compile space. Next, we will include the libraries necessary for this project, which is installed pre-handedly. We will include ESP8266 Wi-Fi.h to use the Wi-Fi function, and include blink simple ESP8266.h to use the blink libraries. Next, we will be using the blink timer function and setting timer as its variables. We will also be using widget LED function and set the variables for the LED widgets in Blink app, which is LED1, LED2, and LED3 with the corresponding virtual pins V1, V2, and V3. To connect the Blink app using Wi-Fi, we will need to type in authorization token received from the Blink app. Next, we will type in our Wi-Fi credentials and Wi-Fi password to connect the Node MCU ESP8266 to Wi-Fi, then to Blink app. Next, we will define the constant integers, which is defining the pins which infrared sensor or IR sensor will connect to Node MCU ESP8266 as button pins. The pins connected will be D1, D2, and D3. We will also define the integers for each of the IR sensors. Next, for the void widget function, we will use the if-else statement, which is if IR sensor 1 is equal to low, LED 1 will be on, else LED 1 will be off. This is explained by when IR sensor detects an object, it will pull the low output, and when the output is low, the blink LED will on, or else the blink LED will off. The same statement also applies to IR sensor 2 and IR sensor 3 to generate the same results. Next, we will be programming the void setup function, which is the first function to be executed in the sketch and is executed only once. We will start with serial begin at 9600 the baud rate along with blink begin. We will also set the input pins for Node MCU ESP8266 by using pin mode functions, which is D1, D2, and D3 as the input. We will also set activation of blink timer with the interval of 1000 milliseconds or 1 second per read for the input pins. Next, we will be programming the void loop function, which will be looping its program function. We will loop the digital read process for each of the IR sensor 1, 2, and 3 for the defined button pins 1, 2, and 3, which are pins D1, D2, and D3 for Node MCU ESP8266. Lastly, we will run the blink function and the timer function to read and send signals to Blink app at 1 second interval. Before we upload the code, we can first verify to check if there is any error while compiling it. After that, make sure that the board device and the COM port is selected correctly. Finally, upload the code to Node MCU ESP8266. After done uploading, we will proceed with the next step. The internet platform used for this project is Blink app, which can be downloaded directly from Google Play Store for Android smartphone. Before setting up the interface, we need to create a new project and set the project name as parking sensor. Then we choose the device as Node MCU and set the connection type as Wi-Fi. Then we create the new project. An authorization token will be sent to the email, which will be used in the Arduino IDE coding later. Next, we will be setting up the interface. Click on Add Widget and choose the LED widget from the widget box. Adjust it accordingly to desirable size. Add 2 more LED widgets which correspond to LED widget 1, LED widget 2, and LED widget 3 for 3 IR sensors. Now we click inside the widget and set the first LED as slot 1 and the input pin as virtual pin V1. The same will go to slot 2 and virtual pin V2 and slot 3 for virtual pin 3. Then press the run button and make sure that Node MCU ESP8266 is connected to the Blink app. This is the sensor which will be used for this project, which is infrared sensor, also known as IR sensor. The front is the infrared emitter and infrared receiver. This knob is used to adjust the sensitivity of the IR sensor, but we will not touch it for now. The 3 pins are VCC, GND, and out. VCC is the power supply pin and it's connected to the power supply pin of the Node MCU. GND is the ground pin for the IR sensor and will connect to the ground pin of the Node MCU, and the out pin will be connected to either D1, D2 and D3 of Node MCU. Now we will connect the IR sensors to Node MCU ESP8266. The Node MCU ESP8266 is connected to the breadboard for now. We will connect the IR sensors according to the pins. For VCC, we will connect to the 3V pin, and for the output pin, we will connect to the ground pin. Now the LED is functional. No, the IR sensor is functional. Next, we will connect the output pin to D1. We will try out for another IR sensor. The VCC pin will be connected to 3V. The ground pin will be connected to ground pin. And the output pin will be connected to D2. IR sensor is now operational. This is the layout of the IoT-based parking detection system, which functions to detect if the parking slots are available or occupied. The parking sensors will then send the data to the Blink app via Node MCU Wi-Fi. If the corresponding slot is not lit, it means the parking slot is available. Vice versa, if the slot is lit, it means the parking slot is occupied. Here will be a demonstration on how it works. All parking slots are now available, as indicated in the Blink app. A driver drives in and parks in parking slot 1. The corresponding parking sensor senses the parking slot is occupied and notifies the Blink app. Hence, the slot 1 is lit, which notifies the parking slot 1 is parked. The next driver drives in and parks in parking slot 3, and slot 3 in the Blink app is also lit, notifying parking slot 3 is occupied. The third driver, which is outside the parking zone, will now know the parking slot 2 is available by looking at Blink app. After the driver parks in, all slots are lit, which means the parking slots are fully occupied. If either one of the drivers drives out, one of the slots will be dimmed, which indicates there is available parking spot. This application is useful in area parking such as shopping mall, office building, so the user can easily identify available parking slots and search it in time easily.
Hello, my name is Chao Chin and I will proceed with the presentation again. This project presents an IoT solution for the parking system issue. This implemented system helps to enhance the efficiency of parking resources, thus leading to reduce the searching time and traffic congestion. We also successfully developed an internet platform, which is a mobile application to receive the data from the microprocessor via internet to know the availability of parking slot in real time. Lastly, I will talk about the conclusion for this project. The conclusion include this IoT-based parking system will enable the driver to obtain info from the availability of parking space in an open area. This parking system reduces time to search for an empty slot in rush hours. Sensor signal from the microprocessor successfully delivered to the Blink application of the mobile phone. This parking system combines the IoT and IR 4.0 will improve the parking facilities, thereby also enhance the quality of life of the citizen. That's all from our group. Thank you.